Welcome to our next lesson where we will be introducing some interesting behavior to our REST API. I'm talking about adding support for working with child resources, where we have a top-level resource that we can consider the owner, and then we have a dependent resource that we can call the child resource. My main focus with this lesson will be designing an API surface that makes working with child resources intuitive. You will see that implementing this functionality under the hood isn't too complicated, but exposing the required API endpoints will lead to some interesting discussion. So let's jump into the code and see how we are going to implement this. We currently have two entities inside of the DevHabit application that we are exposing as resources using a RESTful API. Our first entity is the habit entity, which allows us to implement habit tracking for some behavior that we want to enforce. Then we have a simpler entity called a tag that's just there to allow us to categorize our habits based on the tags that we can create ourselves. Now, with this structure, we don't have a way to associate a given tag to a specific habit. And that's what we're going to implement as part of this lesson. So to achieve this, I need another entity. How you would typically do this in a relational database is by introducing a so-called join table. Now let's go ahead and create an entity in the code that I will call a habit tag. And this is going to represent my join entity that's going to have a direct mapping to my database table. What are the properties that I will need inside of this entity? Well, I need a way to associate this with a specific habit, so I can have a habit identifier property, and I will also need a way to associate it with a specific tag, so I need to have a tag identifier property. And this can also be my primary key in the database. It can be a composite key, and it allows me to uniquely identify this child resource. Now, something else that could be interesting here is, for example, having a created at date and time property so that we can track when this was created. So now that we have our habit tag entity, there are a couple of ways how we can use it. For example, in the habit entity, I can go ahead and introduce a collection navigation property. This can be, for example, a list. I could use iCollection. It doesn't really matter. And I can just call this the habit tags. EFCore will let me define my mapping between the habit and the habit tag join entity. And I can even load the habit together with its tags into memory when I'm querying this entity using EFCore. Now this relationship here is directly pointing to the join entity. But what EFCore allows you to do is to skip the join entity entirely and define a navigation property to the other entity of the many-to-many relationship. In this case, I can have a collection of tags inside of my habit entity, and this is what's called a skip navigation property. I will show you how to configure both of these, and they can each serve a purpose. For example, we can use the habit tags navigation property to make it easier to implement updates to this collection, and we can use the tags navigation property to make querying the database simpler. And at this point, you can already see how our internal contract, represented by the habit type, is deviating from our external contract, represented by our DTO. We don't want to expose internal implementation details, such as the tags or the habit tags, directly on our API. Instead, we want to maintain this control by exposing a DTO. So let's see what we need to do to configure this with EFCore. I will open up the database folder, and inside of the configurations folder, I'm going to add a new class. I'm going to call this the habit tag configuration, and we're going to implement the iEntityType configuration interface and specify our habit tag entity. Now inside of the configure method, I'm going to define my composite key as an anonymous object where I can specify the habit identifier and the tag identifier. If you want to define the actual relationships, you can say that our habit tag has one tag, because this is our join entity, and a tag can be associated with many habit tag entities, which is why I have with many. Now I can also say that we have a foreign key, where the foreign key property, or the column, is the tag identifier. Then I can also have one habit, and in case of the habit, I have a navigation property called the habit tags that I can specify in the with many call. I can also say that I have a foreign key on the habit tag entity, which is the habit ID property. And this is all I need in the habit tag configuration. Now, inside of my existing habit configuration, I can go ahead and add an additional piece of code for configuring the skip navigation property. So I can say builder has many, and I can then specify the tags collection. On the side of the tag entity, we can call with many because it can be associated with many tags, but we don't have a navigation property, so I'm going to leave that empty. And then I can say using entity and just specify my entity type, which is the habit tag entity. And this will be enough to configure my skip navigation property. Then inside of my database context, let's go ahead and introduce another database set. Let's call it the habit tags, and the type will be the habit tag entity. And now I can introduce my database migration. So I will change the startup project to devhabit API. Then I'm going to say add migration, and let's call it add habit tags to represent the new table that we are introducing. And I'm going to output this to migrations/application. This will scaffold a new database migration to create the habit tags table inside of my database, which contains the habit ID and the tag ID columns, as well as the created at column. It's going to define my composite primary key and the respective foreign keys to the dependent tables. So the next time I start my application, this migration will be automatically applied and we can start implementing the required functionality. Now let's go ahead and close down the migration, the database context, both of the configurations, and then let's discuss how we can implement support for associating a given tag with a specific habit. For example, let's start our discussion from the habits controller. I will close down the database folder and navigate to the habits controller. I'm going to also close down the entities as we won't be needing them. And then let's see what it would take to implement an endpoint where, for example, I can introduce a tag to an existing habit. The first thing to consider is whether this is a create operation where we could use something like a post HTTP method, or is this more like an update and we could use a put HTTP method. Because we will be adding the tag to an existing habit, this is more similar to the update habit method. So let's use it as a basis for just ideating what this new endpoint could look like. I'm going to omit the endpoint body and just return an OK result. And then let's rename this to add tag to habit. For example, what will we have inside of the route? We already have the habits from our base route, and we have the identifier, which is our route parameter here. Now, because we are working with a nested resource, it might make sense to also append the name of this resource, which is the tags. Now notice that this URI is fundamentally different from the top level tags URI. If we have just tags in the route, then this is our tags resource. When we have a habit with a given identifier, and then its tags, then this is a completely different resource. And this is how we can expose relationship information from our RESTful API. Now, let's say I want to add a specific tag. Well, for example, I can then append something like a tag identifier to my route and end up with something like this. We already have the habit ID and the route, and I'm appending the child collection tags and the respective identifier of a new item I want to add to this collection. Now in this example, I don't have a request body. All of my arguments will come from the route of the incoming request, and then I can implement the functionality inside of my endpoint. But what are some alternatives that we could explore? If I wanted to remove a specific tag from a habit, I can go ahead and make a similar endpoint to this one and decorate it with the HTTP delete attribute. Let's call this remove tag from habit. And then we can go ahead and implement the required functionality inside of this endpoint. So this is one example of an API service that we could expose to implement working with this functionality. But let's explore an alternative approach and also discuss how we could organize this as a resource. Because fundamentally, this is a different resource from the top-level habits resource. Here, we aren't manipulating the habits directly. Instead, we are manipulating the tags of this habit, which is a child resource. When you encounter a situation like this, I suggest creating a separate controller for managing this new resource. So let's go ahead and extract the API endpoints that I just defined, and let's introduce another controller in the controllers folder. I will add a habit tags controller, and then let's see how we could implement this. I will implement the controller base class this will be an API controller, so I'm going to decorate it with the API controller attribute. And then what is going to be my route? Well, because this is a child resource, I have to include the top level resource, which is the habit. And then because we are always working with a specific habit, let's include the habit identifier as part of the route of this resource. And then we're also going to include the tags. And now this represents our new resource that we want to expose from the API. Now let's bring back the two API endpoints that I added earlier, and let's see what we have to modify here. I already have this base qualification as part of my route definition, so I can simplify my endpoints slightly. In the put endpoint, I would only need to specify the tag identifier, and then in the delete endpoint, I also just need to specify the tag identifier. So now let's consider these two endpoints from a usability perspective. How would the client application integrate with our API? In case of the put endpoint, and let's say I want to introduce multiple tags for my habit, I would need to send multiple API requests to this endpoint in order to end up with the desired state. So an alternative approach of how we could implement this is just have this be a put endpoint, and I'm going to slightly modify the name. I'm going to call this upsert habit tags. We're going to have the habit identifier, which is already part of our route, and then I need to be able to specify a collection of tag identifiers as another argument. Now, because this is a collection, it's much easier if we were to bind this from the request body. So let's create a respective DTO to represent this. In the DTOs folder, you can go ahead and create a habit tags folder, and inside of it, I'm going to add a new class, which I will call upsert habit tags DTO. This will be a public sealed record, and all I'm going to define on this DTO is an array of tag identifiers. And inside of this DTO, I'm going to define one property, which is going to be a list of string values that are going to represent my tag